QC, or the reaction quotient, is a way to kind of see what's going to happen with the reaction, as far as, if you throw a bunch of reactants and products into a container to see what happens, which way is it going to react? Is it going to form more products, or is it going to form more reactants? So the setup is the same as the KC, and what I mean by that is you're going to set it up products over reactants in the same way. Here's a reaction, and for this reaction I've put the KC over here. The KC, the equilibrium constant, tells you kind of the goal of where this reaction is going to go if you give it time. It tells you the ratio of products to reactants that is most stable. And so when you throw together your reactants, it will react until you get to this ratio of products and reactants. Okay, QC is the same thing, except for these concentrations don't have to be equilibrium. It's just a gauge. It's a gauge to see where you're at. It's a gauge to say, oh wait, the ratio's wrong, I need more products. The reaction will shift to give you, or will react to give you more products. So we calculate this number usually from initial conditions, like you're just told, okay, we mix the stuff together, these are the concentrations, and you calculate that number, and then you compare it to KC to kind of see where it needs to go. And again, it's helpful to kind of think of that number as an initial, but then as it reacts, that is a measure of how far you are from KC. And when the concentrations get to where this number is the same as the equilibrium constant KC, then that's where the reaction is at equilibrium, and it will stop going one way over the other. So QC is just a way to kind of see where you are compared to where the equilibrium constant says you should be. The equilibrium constant tells you what combination or what ratio of products to reactants is most stable, and you throw your reactants and products together. They may not be at that ratio yet, and calculating this will help you know which way it's going to go in order to get there. In other words, is the reaction going to proceed to the right more because you need more products, or is it going to proceed to the left more to give you more reactants? And it will do that until the calculated QC is the same thing as kind of the goal. The KC is kind of the goal lowest energy state. And so if it's not at equilibrium, it will react one way over the other in order to reach that point. Remember that QC, just like KC, is products over reactants. And so if your reaction quotient, your QC, is higher than your equilibrium constant, it tells you that you have too many products. And so the reaction will go to the left. It will prefer going to the left and go to the left more in order to get fewer products and more reactants, so that you get to that ideal ratio that is the equilibrium constant. On this diagram down here, this is the situation up here that if you have too many products to reactants compared to the ratio you're supposed to have, then you'll have this situation. Too many products or too much of the products. Too many products, so it will react to the left to get rid of products. If you have too few products, too few, 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 t the QC will be too low, and you'll need to react to the right to get more. And if your QC and KC, if you plug in the current concentrations versus looking up the KC and what the equilibrium constant is for that reaction, if they're the same number, then you are at equilibrium.